There is no denying that large language models and vision language models are evolving very, very rapidly. They are evolving into a highly multifunctional entities with multi dimensions. For example, in the past, we had special purpose solutions for different language processing tasks, such as we had different models for sentiment analysis, different model for parsing, different models for dialogue. But these days, most of LLMs are competent in all of these tasks using a single set of weights. Unified systems are also being built across data modalities. What it means is that instead of using a different architecture for processing images versus text, recent models such as GPT-4o, GPT-4v, Gemini, Lava, they can handle both modalities with a combined architecture. More and more systems are being built of general purpose pre-trained backbones, sometimes called as foundation models, that support a large range of tasks including robotics, bioinformatics, and healthcare. In short, AI systems are becoming increasingly homogeneous in both their architectures and their capabilities. And this paper really shines a light on it from a different angle. This presents Platonic representation hypothesis, which means that it explores one aspect of the trend, which is representational convergence. The researchers in this paper argue that there is a growing similarity in how data points are represented in different neural network models. This similarity spans across different model architectures, training objectives, and even data modalities. If you look at this diagram, for example, there is an image X and text Y. They are projections of a commonly underlying reality Z. And in this image, they are conjecturing that representation learning algorithms will converge on a shared representation of Z and scaling model size, as well as data and task diversity drives this convergence. The central hypothesis in this diagram is that there is indeed an endpoint to this convergence and a principle that drives it, which is different models are all trying to arrive at a representation of reality, meaning a representation of the joint distribution over events in the world that generate data we observe. And this figure conveys this hypothesis that there exists a real world which is labeled Z, which they have measured with various sensors, such as camera shown to the left, which is X. Other projections of these measurements, such as textual description shown, can be produced from the first set of measurements or mediated by some other set of measurements. For example, touch or other camera views. Representation learning algorithms find vector embeddings that statistically model the various measurements and projections. The resulting vector embeddings are all derived from the underlying reality in Z and thereby becoming aligned. As models are trained on more data and for more tasks, they require representations that capture more and more information about Z. And so alignment toward Z increases toward a convergent point as a function of scale. Without going into much mathematical detail, let me give you a bit more overview. For example, if you look at this diagram, this one is again a very interesting one, where what is happening is that vision models are being shown converge as competence increases. They have measured alignment among 78 models using mutual nearest neighbors on places 365 and have evaluated their performance on downstream tasks from the visual task adaptation benchmark. So if you look at the left diagram, models that solve more VTAP tasks tend to be more aligned with each other. And error bars show standard error. On the right hand side, they have used UMAP to embed models into a 2D space based on distance log. More competent and general models, which are shown in blue, have more similar representation. Similarly, if you look at this diagram, this is the capacity hypothesis. If an optimal representation exists in function space, Larger hypothesis spaces are more likely to cover it. So on the left, two small models might not cover the optimum and so find different solutions which are marked by stars. On the right hand side, as the models become larger, they cover the optimum and converge to the same solution. Now, they also have given a GitHub repo where they have given some of the code which you can try out if you have good GPUs, or even do the alignment on different models, but that would require more resources. But they do have this repo. I will drop the link to this paper in video's description and you can read more through it. So if you really want to just say it at high level, as what is happening is that this research thinks that the AI models are converging in a way that is representing our world. And these researchers have analyzed several language and vision models, their learned latent spaces, and the way they measure distances between data points and conclude that there is a noticeable and growing alignment between all of them. This paper makes a hypothesis that different models are all trying to arrive at the same representation of reality. This shared statistical representation of the world is named after Plato's concept of an ideal reality and referred to as the Platonic representation. Now, this paper looks at how each foundation model measures similarity between its data point or its kernel, and then it introduces a kernel alignment metric that determines how close two kernels of two different foundation models are. So I believe that this potential convergence could be very, very interesting for the scientific curiosity. And there is more potential for more efficient transfer learning, better integration of multimodal data, and of course, the development of more general AI system. So what this is leading to is artificial general intelligence, in my humble opinion, because they are converging on the actual reality that consists of all the regularities we know through physics. And I think this is to be expected because it is not just chaos and noise out there. There is something very, very big happening. And if these models get it right, this could be the real artificial intelligence around the corner. So that's it. I hope that you enjoyed it. Let me know, what do you think? If you agree with this paper or not, share your opinion, please. And if you like the content, please consider subscribing to the channel. And if you're already subscribed, then please do me a favor and share it among your friend, your social network, wherever you can, because that helps a lot. Thanks for watching.